Started the recording. So everyone, I want to thank you all for joining the second edition of our St. Louis virtual Splunk user group. As everybody knows, everything's virtual nowadays, so we're going to try to do a couple of these a month. I was lucky enough to get Chris Riley to come online today and talk to us about Splunk for DevOps. Chris is a tech advocate at Splunk, and he can give you a little bit more background on it, but I'm going to go ahead and, you know what, if there's Q&A, Chris, since we have not that many folks, you want to allow people just to, go off mute and chime in and ask questions as we go? All right, cool.
Yeah, I think that'd be great. Yeah.
I think if we get like upwards of 20 plus people, that may not be the way to go, but being at 7 after, I'm not sure if that will be an issue. So.
Sure. Great. Well, thanks, Jay. I don't know how much luck had to do with it. I'm pretty much will talk DevOps with anybody who will lend me an ear. But I'd like to believe you had to try really hard to get me to come and speak, besides calendaring stuff. So this session, we're going to focus a lot on Splunk for DevOps from both a conceptual use case standpoint to actually giving some examples of how to align the product with the use case. And of course, we're talking DevOps, which is fairly broad, but we'll start to go into the specifics of observability, pipeline metrics, etc. First, there's this standard thing. I don't plan on covering anything that's roadmap in future, but in case I do, we have this here. So quick intro of myself. JRD did it a little bit, and I just want to add to that because I think it's important to kind of lend credibility to the person who's up here talking to you. I started my career first as an IT pro here in Colorado doing managed service provider work. Moved into application development, largely a .NET developer, working on OCR toolkits, NLP, things of that sort. Realized very quickly, while I'm pretty good at building prototypes, I'm not good at details. So I realized that the business of doing development wasn't for me. I classify myself as a bad coder turned advocate. And I think that's largely true. The unfortunate side of that is I'm very passionate about application development. And so what I do to keep up with the world of development is became an advocate. So if you can't do it, teach. I get highly involved now with end users, companies who are leveraging the technologies and moving forward into modern application development. What that means for me externally is I speak at trade shows, do virtual events, talk about DevOps, very practitioner focused communication with the community. And then internally, I work with our team to help understand the use cases and how our portfolio of technology fits within the DevOps spectrum. So that little QR code gets you to my social stuff. I do have a podcast. Please connect with me on LinkedIn and Twitter if it makes sense for you. So today we're going to talk about DevOps, and I put this word in here, app dev as well. You could separate the two. You could lump the two together. There's elements of both when we have the conversation about essentially what means is how do we accelerate application delivery at a higher quality and also keep pace with modern architectures. First, unfortunately, and I bet everybody's sick of presentations that start out with definitions, but we're going to go there. There's a lot of terminology out there. I think that the industry largely weaponizes terminology. The good news is that a lot of these terms have very basic definitions behind them. And when you dig into them, they're generally evolutions of previous terms that we're used to using, besides things like no-ops especially. That's kind of the antithesis of all of these. But there's a lot out there. I'm happy to have the conversation with anybody about what these terms mean, because I think it's important. And it's important to be particular and precise about how the terms are used. Generally, for me, I adopt a term once I can relate it to a real world problem. And I've done that for DevOps. I've been championing DevOps for 6 years. Right before that, though, I just told people DevOps was ALM. And I had many Twitter arguments on that premise until I became supporting DevOps, because it's a good umbrella term to talk about a lot of stuff in modern application delivery. As of late, there's a few new terms that I'd like to highlight. One of them is observability, and we can talk in more detail about what that means. But that is a term that I have also latched onto, and I think it makes sense as you look at the evolution of monitoring. The other one is resilience engineering. This is starting to become more and more popular, because a lot of times when we talk about DevOps, we only talk about it up to release, and we forget about the feedback loop. And resilience engineering and the new role of site reliability engineer really help complete that feedback loop. So I'm going to be throwing some of these terms out there. If I ever go down a path that you're just confused about, please let me know. Because again, it's important to be precise about these terms, and it's important not to overvalue what they actually mean, because really the basis of them is to have the conversation, and so we can all be on the same page. So we're here to talk about DevOps, and I just want to do a brief on where we are in the DevOps market from my perspective. I think we're absolutely in the early majority of DevOps, which is good. I miss the arguments of DevOps culture and DevOps being a thing and DevOps only being for unicorns. But I think it's great that we're largely past the argument of what is DevOps and is it a thing, and more talking to how you actually implement it in real world scenarios where environments aren't just trivial and everybody's not just cloud native and a unicorn. That matters a lot. So I say it's largely getting boring, and that's what I mean by that. We get to have those kind of really meaty conversations on how to implement DevOps in the organization. The big trends right now: Kubernetes, microservices, DevSecOps is huge. Observability, as I said. Serverless is funny because I've been saying the last 2 years are going to be the year of serverless, and it's yet to happen. But you certainly do see a lot of ad hoc implementation of serverless environments and aspects of the applications. Shift left is big. Shift left everything. And we're not just shifting left, we're also shifting right. But shift left talks about moving stuff earlier in the development lifecycle. I don't think it means you put it on the developers. I think it means you move consideration earlier in the development lifecycle, which assumes that you need some sort of automation and intelligence there so that it doesn't just all fall on the developer and just mean a whole bunch more human time. And then AI ops. That one I have a love-hate relationship. The growth is tremendous. I was just a part of the Red Hat Summit. The virtual events are just all blurring together for me, but I was just part of the Red Hat Summit today and hearing some of the things. It's hard to hear somebody talk about digital transformation, modern applications, without talking about DevOps. And it's also been really obvious those organizations who don't implement DevOps. Even from an outsider perspective, you can see what a high-performing engineering team is and what a low-performing engineering team is for those applications. Going to take a quick pause. A whole bunch of people joined, which is fantastic. We still have the number where if you want to interrupt me while I'm talking to get clarification, please do. We're here to talk about Splunk and DevOps, and I'm going to go through my slides, and then we'll have a really strong Q&A at the end. This is being recorded, just so you know. All right. So I'm going to go back into the definition again of DevOps, mostly so I don't get myself in trouble in terms of what I talk about at any particular point in time, because I think there's two DevOps. There's the principles, which I will argue are largely the same for everybody, and it all boils down to one simple thing. You want to ship software faster, at a high quality, and you want a pipeline that is repeatable and stable. That's DevOps. Before DevOps, I called it application lifecycle management. You can call whatever you want, but if that's what you care about, which it's hard to find somebody who doesn't care about that, then that's the principles of DevOps. The practice, when you get these two confused, sometimes you have challenges. So the practice is the DevOps engineer, the DevOps organization, it's SRE, it's the automation, it's the infrastructure as code, it's everything is code, it's the monitoring, it's all the tactics of taking those principles and bringing them into the organization in a very real way. When this comes to Splunk land, we are the data to everything platform, which means that we are the data to DevOps platform as well, or I should say DevOps to data. Yeah, that's probably the more accurate way of putting it. So I talk about data-driven delivery chains, which really means that in our software development processes, we think about all of the data that these systems are spitting out and leveraging that to create more sustainable, scalable environments that we can measure. And the purpose of that is, number one, you know, when you hear all the stories about people who have embraced DevOps and moving very quickly, the thing that always pops into my mind is, how long is that going to last? How long are they going to be able to move at this velocity if they haven't planned the guardrails and the processes for moving that fast? So we could talk a lot about automation, release automation, CI/CD, but if we also don't frame that with how we're going to manage that and sustain it, then it could just become waterfall. In 3 years down the road, you've architected yourself into the corner and your delivery chain is just waterfall. That's what we want to avoid. And so data-driven delivery chains is all about making sure that that application velocity doesn't come back to bite you. It's also about enabling your developers, not inhibiting them. That's the dev plus the ops. We all play nice together, and developers are customers, not problem makers. They are your customer. You are trying to make them self-service. You are trying to make them move faster, but also not get themselves in trouble. One thing that is important, especially as you look at, you know, the hiring rates a lot of times in technical organizations, onboarding of developers can be very difficult. You need to get them up to speed very quickly. Data-driven delivery chains help with that because it unifies the environment. It makes it easy to understand what is going on and how to get involved. I already talked about sustainable pipelines. And then the other big thing is this whole shift left thing, which again means quality, security concerns, all of these are brought into the development lifecycle and not only after prod, you know, only after you go into production or right before. So you want to make sure that we address bugs and potential vulnerabilities as early as possible. And having data around those things is necessarily to know if you're doing good, doing bad, and also where you can improve. Really where Splunk comes in to support this is I bucket it into the three categories. In the middle is detection. You know, usually all of this matters when we're finding something to address. So detection with our SignalFX and our ITSI tool. Action based on those events with our VictorOps and Phantom tools. And then inspection, where that's the high fidelity. That's where we go into a particular event and we find out exactly what's going on with Splunk Cloud, but also the entire pipeline inspection. Understand what's going on with your pipeline over a long period of time with the various Splunk apps that we have. And this aligns it back to the whole purpose. Pipeline analytics are important. I'm big on talking to organizations about treating your pipeline as a product. This is a product that you deliver to your developers. You iterate on it, you version it, you improve functionality to it so that your customers, the developers, can do their job better. Pipeline analytics matter in order to do that. And this all leads to what I think is the mecca, which is being able to tie your delivery chain to business value. Can you go from prod to your impact on revenue, reduction in churn, customer satisfaction, etc.? So Splunk butters across the entire delivery chain and the business in order to do that. Application observability. So this is particularly interesting for modern applications, microservices-based applications, Kubernetes, because the complexity of those applications is such that humans can't reverse engineer what's going on. There's interdependencies and contracts between services, the people who build those services. And so you can't just naturally go and dig for issues and where you think something happened and broke. You need that next layer above, which is observability, which really guides you into the unknown unknowns. Better incident response and remediation. This is not a big part of remediation and incident response is mobilizing the right person at the right time. The next part of it is context. That context comes from data. So understanding, again, where the issue actually occurred, ability to deep dive into the logs to get that full fidelity and troubleshoot the issue, which all leads to getting to bed faster if you're paged at midnight. High fidelity, talked about that. And then finally, visibility across teams, especially dev, security, and operations. So the next 3 slides, my disclaimer. These are all examples. These are 3 different ways to frame Splunk into an architecture of an enterprise. There's a lot of different ways to do it. And all of these are in the process of continually being defined as we look at more and more use cases. And there's a lot of flexibility. So these are me attempting to bucket the technology so that it helps frame the conversation and give organizations a chance, a jumping off point to bring the technology into their organization where it fits. So the first one is looking at Splunk technologies from an application architecture and cloud architecture perspective. So you have monolith to microservices, on-prem to cloud native. You could also think of it as going from heritage to modern architecture applications. Enterprises have both and all combinations of all of this, and they probably will forever. I'm not advocating for everybody going immediately to microservices, as some have. It's more finding the best place to connect the dots. Now, the great benefit of Splunk is that it does butter across all of these, the hybrid cloud, the multi-cloud, and it ties all of them together very nicely. So first thing you'll notice is VictorOps is right in the middle. You know, largely VictorOps, it's an incident response tool. We all understand broadly what that is. It's getting the right person in the right place at the right time. What's unique about it is that it has organizations connect their stack together from their on-prem, hybrid, to their most cloud-native aspects of their stack. And that's very useful because it helps to create continuity across the organization and visibility that a lot of times you didn't know was there. A lot of times you'll see organizations start connecting their stack together, realizing disconnects that they never knew were there before. And so that's why I put it right in the middle. VictorOps is a SaaS-based tool. It is easy to onboard for developers and those of the cloud-native mindset, but it integrates with all of the tools within the organization to make a nice pivot point. That's also where I see ITSI kind of fitting, is in between the hybrid on-prem with the cloud-based architectures and applications. Splunk Enterprise on-prem, of course, is going to be for your on-prem cloud, private cloud. And then you're going to look towards Splunk Cloud for your cloud-native applications. This is also where you see Phantom coming into play, which crosses all of them. It does. But it's also very interesting when you start to talk about using runbooks and auto remediation for your cloud-native infrastructure in response to incidents that happen and are fired maybe from VictorOps or SignalFX. And then SignalFX, especially SignalFX APM, is tailored towards those cloud-native applications, microservice-based applications. The next way to look at it is on the delivery chain perspective. So all the way from code to prod. It could be plan to prod as well. And you can layer Splunk here in various ways. First is Splunk Cloud, Splunk Enterprise is buttering across the entire delivery chain, both from a point event happens, I need to inspect, I need a fidelity. Two, I need to see what my delivery chain's doing so that when somebody comes to me and says, okay, you're releasing every day now, how has that impacted our business? You need that across the entire flow in your entire pipeline. From deployment into production for your modern applications, modern application architectures, including serverless, you have SignalFX APM. And then on the response side, you have Phantom and VictorOps. So here's another way to slice and dice it. Of course, for example, you could use VictorOps in a vulnerability scanning type scenario, or even in CI/CD testing type scenario. But it's another way to kind of bucket the technology so that you can start to plan an architecture and slot the tools where they make the most sense for you. And then my next example is across the tool chain. Again, from code to monitoring, having collaboration elements with VictorOps and also incident response, and the integration into all of your other tools. So now I'm going to jump into the specifics, and I'm going to do a little demo for each of these sections. How are we doing time-wise? Pretty good.
Yeah,
Cool.
we're barely at 30 past the hour.
Nice. We'll have plenty of time for question and answer. Did anybody want to pause me at this point to ask questions before I go into detect, inspect, and act, and a little bit of a demo?
Hey, everybody, if you're in here and you do have a question, you are automatically muted, so you'll need to unmute yourself to ask. Feel free.
By the way, this is not a beer, it's kombucha.
Nice.
Not ready yet, maybe after this one. All right. So back to the slides. So let's talk about SignalFX and ITSI for detection. What the screenshots you see are SignalFX related. So it's going to be more on the APM side. This is where we're going to get our metrics, traces, and spans. If you've heard about the 3 pillars of observability, it's metrics, traces, and logs. One of the questions that always comes up is, what is the difference between all of these? They all have their purpose. Their foundation in all of them is logs, essentially. Metrics are essentially what you decide to measure. That's what we see here with the SLA, request of latency, and so forth. And it's really kind of that snapshot. Can I make a quick decision? Yellow, red, green. What's going on with our application? What I decide are the key metrics to judge the availability and the success of my application. Could be red, rate, error, duration. Could be whatever makes sense for you. It usually goes from the customer back in. You decide what metrics matter. So that's the snapshot. Traces are what you see on the upper right, which is connecting multiple services together based on their dependencies. And it matters a lot because where an event fires, may not actually be the cause of the issue. It could be a database, but your API layer is the one screaming at you. So you need to be able to traverse through that. A human can't do that naturally for most applications. Uber has thousands of microservices. A typical modern application will have 30 to 50 microservices. But even at that level, it's really hard to understand the relationship between all the services and the contracts the services have with each other. A contract is how the services agree to communicate with each other, essentially. And then spans is the bottom right there. It's basically connecting them all together, showing the time spent within each of these services. The reason this is unique is because a log is the record of what happened. This is the relationship of all the things that have happened. And in order to do that, you need to be able to correlate them together in an intelligent way. Modern application architectures, even the most modern companies, including us, have some combination of stateful and stateless applications. But when you look at modern architectures where you have Kubernetes, you have pods, you have the services within those, maybe even serverless, but you also will probably have stateful environments, may or may not be in containers. They're going to be your backend. It is impossible from just a standard kind of dashboard monitoring perspective to traverse that in any efficient way without having this type of technology and moving to the next level of APM. And of course, all of this is to avoid the hunt. So the technology should help you know what you didn't know and then get to issues as quickly as possible. All right, so let's look at a demo. First thing I want to show you is the Kubernetes Navigator. I'm going to start, let me drag my tabs around so I get my order right. So I'm going to start here. And Kubernetes Navigator is relatively new. It's a product embedded in, or it's a feature embedded inside of SignalFX. It's that snapshot view of your clusters, the nodes, and the pods within them from a very visual kind of standpoint. Can I quickly assess what's going on and if there's any hotspots, blast radius that I need to be aware of. So it may not necessarily be event driven. It generally is not. This is something that you would have up as a part of a traditional NOC, maybe. If I open any of these clusters, I can start to deep dive into the nodes and the pods themselves and start to get a sense if there's anything going on specifically here. Now, a lot of times these visualizations are good, but if you can't take action to the next level, they don't provide a lot of value. And so that's really important that you're able to deep dive in and start to get to that next level. Because a lot of times, you know, CPU limits, memory limits are just natural. Maybe you're running a job. You don't need to raise all of the alarms just because you see CPU getting pegged on a single pod. So we can open these up and we can start to see our standard metrics associated with them. Similar, so this is specifically designed for Kubernetes, but if you're familiar with ITSI, whoops. You have the similar slice and dice. And this is really nice because there creates some parity between the tools in the various environments that you have. And you can go in and start to build dashboards for very point and click dashboards for the various infrastructure that you have. In addition, we have Connect for Kubernetes that also works for Splunk Enterprise and on-prem. So I'm going to go back to Signal, and now I'm going to focus on the APM side of things. So the first thing I want to demo, I think this might mostly just because I like demoing this, is the relationship between modern applications and kind of the environment. So here you see we have a lot of things. Custom dashboard set up for an application that is kind of a catalog type application. We have our standard red metrics here, time series. We have a really nice service map, which is great. So I can see the, our entry point is the API gateway and how it relates to the shopping cart and checkout and so forth. In modern applications, every button has a service. It's quite amazing how they're built. Oh, I need to filter this quickly. Now you know my email address, which is good. All right, so I'm going to refine the data set to be me, because I'm going to do a push deployment. I'm going to do it from my phone. You can't see it, but I have a little automation where I can do a push deployment of a canary release. So
Chris,
I just
were you meaning to show something different besides the deck?
Oh, yes.
We're still on
Did
the
you not? Well, that's a bummer. That means you didn't see the ITSI stuff. Hold on one second. Should share my whole screen, huh? I'm sure you've all seen the memes about the things that happen in every single meeting.
Yeah. Yeah, now we can see your browser. Thanks.
All right. Well, we're going to rewind. I might go through it a little bit quicker than I did last time, but we're going to go back and I want to show you the Kubernetes Navigator quickly that I was talking about. Again, this is the quick snapshot point of view of your clusters, your nodes, and your pods. And it allows you to very quickly deep dive in to get are things good, the bad, anything I should pay attention to, maybe from kind of a knock ongoing maintenance perspective, and get the metrics associated with this. What's nice is it's tailored for Kubernetes, which means it's built for Kubernetes, easy to set up, and easy to get this visibility. A parity to that is in ITSI. So if you've already seen ITSI, you know that it's a great interface for going in, doing point and click, building dashboards based on metrics that I care about for my usually stateful infrastructure on-prem. But there also is Connect for Kubernetes here if you want to bring Kubernetes data in, also similar to Signal. Now going back to Signal, and now the demo in the APM world, because APM is different. APM is not just like monitoring your infrastructure. There's many more elements associated with it, and variables to what you're actually monitoring. So I'm going to go to my catalog service. And like I said, that this dashboard is going to be your standard metrics. Well, sharing my screen did not help my cause in terms of internet. And at the top, we have our red metrics. We have a nice service map for digging in and visualizing the application layer, the relationship between the services. We see that our API gateway is where everything starts, goes into our shopping cart checkout. Also latency, see that everything's good, everything's green so far. Now what I'm gonna do is run a canary deployment from my phone, because a lot of events happen during canary, or I should say the frequency of events and issues is higher during releases, put it that way. So I just did a deployment, and what we should see here is that things start to degrade. So we know that we have things going on with our services. Something has broken, And in this case, we have implemented an automatic rollback. So we'll see very quickly that it's automatically done a rollback due to the issues that it ran into. Can you guys hear me okay?
Yeah, I don't have any audio issues, Chris. You're
Okay.
coming loud and clear.
All right.
I'm good. Thanks, Chris.
Okay, good. So this could be with Phantom. It could be with a run book. It could be with automation that you've built. But it is a cool example of how to address that velocity in modern application. Excuse me. Now I want to take a different look at it and actually dive into kind of the traces perspective. Again, we're looking at service maps here where we want to look at the various services and their relationships. So let's say we get an event from the API, but the issue is actually in the database. Right now, everything looks good, and we're not viewing any sort of issues here, but I can navigate into this traces view, and I can see, where issues have occurred in the past, dive into them all from this interface. If you're familiar with our acquisition of Omnition, all of that has started to come together into a unified view for really what ends up being kind of an APM for microservices. So the point of all this technology that I'm showing is mean time to detection is very quick, ideally before your customer detects it and goes on Twitter, and the context and the ability to deep dive in and figure out where the issue actually lies. So if you need to get to a log, you can, and you get to the right one to address the issue is high. We all know that a lot of times the people who are on call are not the people who necessarily have the domain expertise. So you have to give them the right tools to know where to go and what to do. Okay, I'm gonna bounce back to the slides quickly. And now I'm gonna go into inspection. So 2 ways to look at the inspection. You have depth and breadth. Depth is logs. The deepest you can go is the logs. And that is high fidelity. That is where you just have to get all of the details of a full, maybe stack trace. You also have breadth. Breadth is the understanding of all your things related to each other. So depth is logs, breadth is value stream. That's where Splunk, Splunk Enterprise, and Splunk-based apps come in. So we already know, the foundation of Splunk is being able to find those logs and get to the right data as quickly as possible. And then with Splunk base, you can start to bring in data from your tool chain itself. I'm not going to demo the logs because I think we all kind of understand that, but I am going to do just one example or 2 examples, I guess, of the delivery chain stuff. Now, the reason delivery chain matters is because software is eating the world, yada, yada, developers are building software. But at the end of the day, we're doing all of this because we have customers that pay us money. And we want to make sure that we're getting as much value to them as we possibly can, or make sure that they don't leave us because they found an application that was better. So to do that, you really need to have KPI and metrics across everything. So I'm going to switch back to my browser. And we're going to go to the first thing, which is, this is a dashboard I really like. And it actually correlates to the live demo I'm about to do with VictorOps. It is an incident response dashboard. It must not be running right now because there's no cost added there. But the purpose of this dashboard is to look at what is the cost to your business of incidents. How many incidents have you had over some amount of time? How much unplanned work there was, because time is money. Your engineering time not only is expensive from the salary that you pay them, but context switching is also very expensive, going from building applications to firefighting. So this is a really nice dashboard that pulls it together. We're going to expect to see more incidents during the week as we have more frequent releases. That's exactly what we see here. And this is going to allow us to see who's on call and deep dive into incidents, even the logs associated with those incidents, to get a better picture of what's going on. Similarly, if you've ever seen in our Splunk base, all the various applications we have for monitoring your delivery chain. There's DevSplunkOps, which is around tool adoption. You have Jenkins for monitoring your CI/CD processes, getting a sense of the relationship between, you can measure the relationship between commits and Jira, all the way down to how it impacts bugs in your application, and then the release process in the middle. I think most of the examples I've seen of this is definitely been in the CI/CD area, but there's no reason you can't tie it all together, and there are some really interesting examples of that happening as well. These are all available in Splunk base, and all the common, or I should say most of the common tools for application lifecycles are already in Splunk base. All right, so that is value stream and Splunk. And the next one is VictorOps and Phantom. So this is the act side of it. What do you do when SignalFX says something's broken, or another tool in your stack? Because we all have varied stacks. How do you take action? How do you mobilize the right people? How do you give them enough information to make sure they know what to do when something comes up? So what I'm going to do is show the VictorOps demo. Okay, it looks like it is running. No, it's not. Let's see. Somebody's been in here resolving incidents. All right, I'm going to pause just for 1 second and get the demo going again so that I actually have incidents to show you. So in a few seconds here, we should see some new incidents. Somebody's obviously been demoing and resolving incidents. So all the ones that have fired so far have been warnings. Now we have a Nagios incident here. You may or may not be interacting with the product from the web interface. You may be interacting with the mobile interface. Most of our users prefer to get alerted via push notifications or phone call or text. Once you have acknowledged an alert and you need to start diving into it, what you're going to do is open up the incident. And I want to point out that incident response is distinctly different from alerting and event management. And the reason for that is incident response has the addition of audit trails, postmortems, and correlating events, and also giving more tools to the person who is on call. So we opened up an event. All of this data is being thrown from whatever monitoring tool. In this case, it's Nagios. Could be SignalFX, could be Splunk. I can go into the timeline, and if I'm the person on call, I'll just acknowledge this, which is basically saying, I'm going to take it on, it's mine. Now, let's say I'm not the right person. Let's say that I open this up and it's out of my domain, or it's a catastrophic event and it's cascading and I got to get more help in here. First thing I can do, instead of always calling that one person who we always have resolve all issues, we can have this add responders feature, which intelligently recommends people based on previous incidents they've responded to. Gustavo and Walter are not currently on call, so don't add them because they're not in a rotation. Any of these other people, if I select Jesse, now Jesse's going to get paged. Let's say that this has gone and elevated to something much bigger. We now are approaching this idea of a war room where we can get everybody in the same place. We have bidirectional with Slack, We can add conference bridges, and it helps us bring everything together so that we can all triage the issue and work together to solve it. The other cool thing that we have as part of VictorOps is similar incidents. So this is pulling historically incidents who have been resolved and how they were resolved. So if I'm on call, I can start to see the path that was taken. And maybe that was a run book. So we also embed relevant data with a rules engine into incidents in case we already have a post-incident review, a run book, a JIRA ticket, a ticket in ServiceNow to address issues that are similar to this one. Finally, let's say that all did the job and I've resolved the incident. We're good to go. Everything's gone back to steady. All of this now feeds into the idea of a postmortem, which we can feed back into the organization and hopefully create a phantom workbook, run book, whatever, to make sure that this does not happen in the future, because we want to automate anything that's happening on a regular basis. The number of people I talk to who get events every day, hundreds of them, for disk full errors and haven't yet automated that problem, that's something that you want to obviously move towards. Big part of VictorOps is going to be the integrations with the collaboration tools, your monitoring tools, and the rest of the stack, including API, if you want to build custom integrations on top of it. So that is the action side. So back to tying it all together, this is all about supporting a data-driven delivery chain. Splunk tools come in and help create visibility from a breadth standpoint, fidelity all the way into logs, but also intelligent detection via SignalFX or ITSI to incidents in the scenario where the complexity has outgrown our ability to deal with it. And then finally, when it comes time to mobilizing people, VictorOps to tie it all together. All of this matters because if you're going to have a sustainable delivery chain over a long period of time, you have to worry about the pipeline and not just the code that the pipeline is shipping. One of the things that I didn't dive deep into, I mentioned earlier, DevSecOps is a big thing. It's becoming bigger and bigger. Rolling vulnerability scanning into this and relating operational drift from dev test to prod is also a very interesting use case, and the technology can be used to support that. It's predominantly VictorOps and Splunk Core, Splunk Enterprise to do so. So I'm going to put the thank you slide up, and then I think we have time for questions. Connect with your Splunk reps and SEs to talk about, and specialists to talk about building out a DevOps, conceptualizing how you would bring this technology in to support your DevOps journey and digital transformation. Pick our brains from a broader perspective. My job is to understand the industry. And so I'm happy, other people on the team are happy to share our knowledge of just what's going on broadly in the market. And then some of our DevOps specific content, if you check out the VictorOps blog or the Splunk blog under the category or the tag DevOps, there's a lot of great content there, as well as our weekly webinars on the SignalFX side. All right. So let's open it up for questions. Thanks everybody for joining up to this point and listening to me.
Yeah, thanks, Chris. This is great stuff. Everybody feel free to go off mute and join into a discussion or ask questions.
Thanks, Chris. Thanks, Jay. It was a really wonderful presentation and it was very informative as well. So my question is more specific to AI Ops. In my previous organization, I was working on the AI Ops implementation project, and instead of VictorOps, we are using MoveSoft and PagerDuty. Now, what benefits does VictorOps have over other tools when it comes to event management? And also because it is one of the Splunk internal products, so how this ecosystem can help us gain more visibility, not only on the AI Ops side, but also on our DevOps ecosystem.
Yep. Yeah, so I said earlier, I have a love-hate relationship with the term AI ops. A lot of development is being done there, but I always prefer to talk about it from the use case perspective up. And the use case perspective up, let's start with your first question is incident response. Actually, if you want to connect with me, I did a podcast episode with Software Engineering Daily just on AI ops and incident response, and I can share that with you. But there's two things. It's all machine learning based. We have reconciliation of similar incidents, identification via the rules engine of runbooks and so forth, and then recommended responders. So all of these are intelligence intending to surface relevant data to the person on call to take action. The action piece of it is where you're going to look towards Phantom and building out the automation. From a monitoring perspective, both SignalFX and Splunk are leveraging what I think you're probably referring to with similar to Mooksoft, which is anomaly detection. So the ability to anticipate something happening prior to it actually happening in a time series of data. And to do this, and especially in SignalFX, it's important that you don't have sampling. So intelligence is being applied to the stream. We have some really cool stuff that's going to come out in the future around that I can't speak to right now. But already with SignalFX, data is coming in as a stream. We are processing and metricizing on a stream, which allows us to apply that intelligence, that anomaly detection on the stream itself, which is very cool. As you know, if you sample, you're throwing away a large chunk of the data, which makes the precision of that anomaly detection not as successful.
Thanks, Chris. That answers my question.
Great. Yeah, good stuff. Anybody else have any comments or questions while we have Chris on the line today?
Terminology, anything. I was hoping that somebody was going to say, what the hell is resilience engineering? So I'm just going to answer that. Because it is coming fast and furious. So SRE is a new role, site reliability engineer, that was originally kind of championed by Google. Doesn't mean we're all going to be Google, but it's useful to understand where they're coming from and see how you can apply it. As a part of that, because I've been so frustrated with the fact that a lot of organizations don't consider the feedback loop from what happens in production back into planning. Resilience engineering kind of gives that perspective, and it's about planning for failure, essentially. So planning for the inevitable breaking and what you can do to respond to it. Ultimately, it's all the same technologies that we've been talking about, but it is a different strategy. And I think it's really cool. And resilience engineering is picking up more and more as a concept. Great. Well, good. Well, thanks everybody for joining. I really enjoyed it. Please connect with me if it makes sense. Please connect with your rep specialists and SEs and see where maybe the Splunk technologies would fit for you. Oh, whoa. I didn't know you could do that. How did you do the thumbs up? It was cool. Go ahead.
I would like to know more about your podcast. If you can share the link or I can find it somewhere.
Yes. So this is the one in particular. My podcast you can find by looking up Developers Eating the World and wherever you listen to podcasts. The Software Engineering Daily one, either you can connect with me on LinkedIn and I'll send you the link, or Google Software Engineering Daily Chris Riley. It should pop up. It's all about machine learning and incident response.
Sure. Thanks a lot.
Chris, were those links part of the content links you sent me that I posted on your user group page?
Not the SRE daily one.
Okay.
But my developers eating the world was. Yeah.
All right. Yeah, because I did post.
And if you want to send out an email with the slide deck, the recording, and those links, that would be great.
Yes, I plan on doing that. Hopefully when it processes by the end of today or tomorrow morning.
Yeah, it takes a while.
Yep.
All right. Well, thank you. Thanks, Jay.
Thank you, everybody. Thanks for joining. Chris, thank you very much for spending an hour with us and walking through this stuff. It was really good stuff. Appreciate it.
Absolutely. Bye-bye.
Bye, everybody.
Thanks, everyone.